Are you wondering how to pass your dosage calculation exam in nursing school? In this video, I will walk you through how to get every single dose calc question right every time. And be sure to stay until the end of the video because, friend, I am giving you the must-know tips that you need to follow or you will really struggle on your dose calc exam. Now, hit that subscribe button and click that notification bell and let's dive in. So before we dive into walking through some dose calc practice problems, there are some things that we need to get clear on first. Number one, following our simple 6-step process is going to make all of the difference for you in nursing school. There are a lot of different ways that nursing instructors teach dose calc, and to be honest, so many of them are just not helpful. I have received a ton of emails from students who love this dose calc system that we have created because it works, my friends. So please stick with these 6 simple steps and you will be golden. Now, the second thing we need to agree on is that we do not memorize any formulas. I know I get a lot of pushback on this, especially from beginning nursing students, but here is the deal, my friend. Trying to memorize random formulas might work for super simple, basic dose calc problems, but it will fail you as you try to solve more complex problems like Pitocin calculations, heparin calculations, and where you have to use multiple conversion factors in one problem to get the right answer. I do not want you to get to your exam, have a bunch of random formulas memorized, and then at that exam realize that they don't work with the question that your dose calc exam is asking you for. I see it happen all the time. Do not do that to yourself. So instead, we use dimensional analysis, which in my opinion is 1,000 times easier, and it works every time, no matter what problem you are trying to solve. So let's lay out the simple 6-step process first, and then we will dive into some practice problems so you can easily see how it all comes together. Now, if you want this full step-by-step guide to dose calc plus over 100 practice problems and flashcards to help you learn all of the conversion factors that you need to know, you will definitely want to check out the nursing school dose calc box, which has all of these goodies and more resources that you need to help gain confidence with dose calc and pass. So the link is down below in the description for you to check out all the details. Okay, so here are the steps. Step number 1, figure out what unit you need to end up with at the end. What is the question actually asking you for? Now, this is step number 1 because you need to find out what you need to end up with at the end so that you know what conversion factors to use in the middle. It's really important that you do this first or you will end up with the wrong answer. So step number 1 is that you figure out what you need to end up with at the end. Is it milligrams? Is it grams? Is it drops per minute, milliliters per hour, number of tablets? What is it? Figure out what the question is asking you for. Now, step number 2 is to figure out what the prescriber ordered. What is the original order that we are trying to convert here? And then step number 3 is to decide what conversion factors to use to get from A to B. What medication or unit does the question make available to you? Are you needing to convert grams to milligrams or minutes to hours or milliliters to drops? Now, pick out the information that relates to the answer that you need and cross out any unnecessary details. If the test is on paper, I like to actually physically cross out the information that I do not need to keep me from getting distracted. That can be really helpful. Now, step number 4 is to just solve the problem. You multiply across the top line, multiply across the bottom line, and then divide both of those numbers. Now, this is a super awesome math trick that does the conversions for you. And one of the top reasons really why I love writing out dosage calculation questions this way using dimensional analysis, it makes it so much easier to get the right answer. Now, don't worry if you can't visualize all of this just yet. Hang on with me. We will go through lots of practice problems to help it all come together for you in a minute. And then step number 5 is to write out the the answer appropriately and follow the correct rounding rules and the rules around the use of zeros. Here's 2 rules that you need to know. The first rule is that when you are using this dimensional analysis method, you don't round the answer until the very end. So as you're multiplying across the top and multiplying across the bottom, you just write out those numbers exactly how they are. Do not round them until after you divide and then get the final answer. Now, if you round the top and the bottom numbers before you divide, then the answer might be off and you will get it wrong. And the second rule that you need to follow is to remember this mnemonic. Nurses are leaders, not followers. Now, this means that you include leading zeros, but not trailing zeros. So let's say that your calculator said something like 0.5. Well, we wouldn't write this answer as just 0.5 because imagine how easy it would for that decimal point to get lost and then the dose to turn into 5. And we definitely wouldn't write it as 0.50 for the same reason. That decimal might get lost and someone might think it says 50 rather than 0.5, and that would be very bad. The only correct way to write it is 0.5. Even if the decimal gets lost, it will look like 0.5, causing other nurses to double check where that decimal is. And finally, the last step before we move on and do several practice problems with you is to check your work. It's really important to check that you got it right because we all make mistakes, my friends, sometimes, but the patient's life could depend on this. So it's really important that you be diligent and double check your math. Take a step back, take a deep breath, and do the problem again. Safe nursing practice is always your #1 priority. So now that we've gone through the steps for Dose Calc, I am going to have our lead nurse, Nicole, walk you through several Dose Calc practice problems to really help this come to life. And then let's meet back here and go through some key tips that you absolutely need to remember for your exam, or you might accidentally make a mistake. So let's walk through the practice problems and then come on back.
All right, let's dive in. So Mr. Roth, your patient, is ordered for 1 gram of acetaminophen via IV every 6 hours around the clock. He's not to exceed 4 grams in 24 hours. Following his appendectomy, you go to hang his acetaminophen and Mr. Roth asks you how many milligrams of Tylenol he's getting this time. So how many milligrams are you giving Mr. Roth? So first step, we're going to figure out what we need. So what we need is going to be how many milligrams. That's what the question is asking for. So we're going to want to end up with a unit of milligrams. The next step is going to be figure out what's ordered. So our order is going to be 1 gram because that's what he is ordered for, 1 gram. Now our conversion. So we know that we need to get from grams to milligrams, and 1 gram equals 1,000 milligrams. So we are going to set up our conversion to solve. So we are going to do 1 gram, that's what he's ordered for, over 1. And we know that 1 gram down at the bottom here, so we can cross it off, is 1,000 milligrams. Cross off our grams, multiply across the top, and we get 1,000 milligrams. And divided by 1,000 milligrams is our answer. All right, let's dive into how we would use our 6-step process for solving for a tablet. Okay, so your patient is being transitioned to digoxin, and you're explaining to them that they'll be taking 0.5 milligrams of digoxin every morning. He asks how many tablets that will be. You look at the medication that was delivered by the pharmacy for his discharge, and the label reads 0.125 milligrams per tablet. How many tablets will your patient take every morning? All right, so step number 1, we're going to figure out what we need. So what we are solving for is tablets. How many tablets? So we need that as our ending unit, tablets. Number 2, figure out what the order is. So what is our order? So our actual order is going to be taking 0.5 milligrams of digoxin. So 0.5 milligrams every morning. So now he's asking how many tablets. So we need to get from milligrams to tablets. So we are going to start solving. So we know that our order is 0.5 milligrams over 1. That's one of his things. And then we know that we need to get from 0.125 milligrams. So we're going to put our milligrams under here, 0.125 milligrams. And there's 1 tablet. All right, so we can see what we're going to do is multiply across the top, multiply across the bottom, and then divide them out. So we're going to end up dividing 0.5 by 0.125, and we are going to get 4 tablets. And that is our answer. All right, now let's solve one that has drops per minute. So you're getting your patient's IV fluid ready while you're waiting for them to arrive from the OR following their appendectomy. They're ordered for 1 liter of normal saline to run over 8 hours. You're using macro drip tubing at 15 drops per ml. How many drops per minute will the patient receive? All right, let's start with number 1. What do we need? So what we need is going to be how many drops per minute. So drops per minute. Now, what is ordered? So our order is going to be 1 liter of normal saline over 8 hours. So 1 liter over 8 hours. Now we're going to go from hours to drops per minute and hours to drops per minute. So we're going to need some conversions. We're definitely going to need to do from minutes to hour or hours to minutes. So 1 hour equals 60 minutes. And we are at liters, and we're definitely going to need to go somewhere in there to milliliters. So we know that 1 liter equals 1,000 milliliters. Now we are going to use this 15 drops per ml. It's a conversion that the problem gives us, so we don't need to worry about writing it in here, but we are going to use it when we go through our dimensional analysis. Now let's get started. So we are going to start with 1 liter over 8 hours. Now we want to get from liters to milliliters, so let's throw that one in here. So 1 liter is going to go down here, so we can cross it off, and it's 1,000 milliliters. We can cross off our liters there. Then we're going to need to get rid of this hours. So we are going to put our hour up here, 1 hour, and 60 minutes is down here. So we can cross off our hours. We are at milliliters per minute. Now we need to get to drops per ml, or drops per minute, sorry. So let's put in our drops per minute up here. So we want to get rid of this ml right here. So we're going to put our drops up top, 15 drops per 1 ml, and that is going to cross off our ml, and we are going to be left with drops per minute. So we know we're ready to solve. We're going to multiply across the top, and we're going to get 15,000, and then multiply across the bottom. We're going to get 480. Divide them out, and we're going to get 31.25 drops per minute, and that is our answer. All right, now let's run through a problem where we're going to have to solve for milliliters per hour, or how we're going to set the IV pump. So your patient Sandy is NPO due to her gastric ulcer. She's ordered for maintenance IV fluids of 2 liters lactated ringers to run over 12 hours. How many milliliters per hour will you set the IV pump to run at? All right, first things first is what do we need? So need is first, and we are going to solve for milliliters per hour. That's what we want to end up with. So milliliters per hour. Next, we're going to come up with our order. And our order is going to be 2 liters over 12 hours. That's how it's ordered. So 2 liters over 12 hours. Now, let's get our conversions. So what conversions do we need? From here, we can tell we go from liters to milliliters. So we know we're going to need to do 1 liter equals 1,000 milliliters. But then we have hours and hours, so we are good. So let's start setting up our conversion. So we're going to do 2 liters over 12 hours. And then we're going to get our liters. We want them to cross off. So we're going to start with 1 liter down here is 1,000 milliliters. Then we can cross off our liters, and we're left with milliliters per hour. So now we can multiply across the top, multiply across the bottom, and then we can go ahead and divide it, and we are going to get 166.67 milliliters per hour. Okay, now we're going to get a little bit more in depth with how we are going to do our IV pump, and we're going to do it based on weight. So you're hanging your dexamethasone on your patient. The order says 0.8 micrograms per kilogram per hour, and the bag you receive from pharmacy says 1 milligram per 250 mLs. Your patient weighs 189 pounds. How will you set up your IV pump? So it looks like there's a lot going on here, so let's definitely break it down into our 6 steps. First thing is going to be, what do we need? So what do we need to end up with? We need to end up with how we're going to set up our IV pump. So we're going to need milliliters per hour, since that's how all IV pumps run. Next, we're going to figure out what our order is. So our order is going to be our 0.8 micrograms per kilogram per hour. So we know that we're going to definitely need some conversions in here. So we know we're definitely going to need 1 kilogram equals 2.2 pounds. And we are also definitely going to need to go from micrograms to milligrams because we have milligrams up here. So 1 milligram equals 1,000 micrograms. All right, and we have our weight in here, so we're going to need this information, and we're going to need this. So let's get started, and we'll try to chip away at this. So let's start out with the weight, because we know how to convert that. So 189 pounds over 1. And then we're going to get rid of our pounds. We want kilograms, so we're going to do 1 kilogram up here and 2.2 pounds down here. Then we can cross off our pounds. We're good there. Now we're at kilogram. We have kilograms up here, so we can do our 0.8 micrograms per 1 kilogram. Now let's remember 1 kilogram per hour. We know our ending is hours, so let's just keep that in mind. 0.8 micrograms per 1 kilogram. And we know that we need to get 1,000 micrograms down here and 1 milligram. That way our micrograms can cross off here. Next, we're going to need to get rid of this milligram because there's no milligrams over here. So here we're going to jump into our 1 milligram per 250. So we are going to put our 250 up here so that we can end up with our 1 milligram down here and cross it off. Then we are going to be left with our milliliters per hour. Remember this from right here was our 8 microgram per kilogram per hour. So we are going to multiply across the top and multiply across the bottom. Across the top, we're going to get 37,800 and then 2,200 and divide it out. And we are going to get 17.18 milliliters per hour. We know our conversion is right because all of our things are crossed off. We are left with what we need, milliliters per hour. Whoops, we didn't cross off our kilograms, but there they are. And we know that we are good with our rounding rules because the IV pump will read this. So we are all set. Okay, now let's go through how we would solve for heparin problems. Now, your patient Mary is recovering from a TBI and is on heparin therapy. The pharmacy sends up a heparin bag that reads 50,000 units per 1,000 mLs. The order is written to run heparin at 75 milliliters per hour. How many units of heparin is Mary receiving per hour? Round to the nearest hundredth. All right, so let's start the way we always do, what we need. So what we need is going to be units per hour, because that is how many units of heparin Mary is receiving per hour. Now, what is ordered? So we have ordered 50,000 units per 1,000 mLs, and we know that it's running at 75 milliliters per hour. So let's start right here. 50,000 units per 1,000 milliliters. So we're going to start here. We don't have any conversions because what we just need to get is units per hour. We have units here and we have milliliters here. So we should be good to go. 50,000 units per 1,000 milliliters. Now, how are we going to get rid of this milliliter? We're going to put 75 up here, milliliters per 1 hour. We are going to multiply across the top because when we go here where milliliters are crossed off, we're left with units per hour. Multiply across the top, it's going to be 37.5, 1, 2, 3, 4, and 1,000 on the bottom. Divide it out, and we're going to get 3,750 units per hour. Alrighty, let's go through a pediatric problem. So Donna, your 7-year-old patient, is being discharged home with Tylenol. She's prescribed 12.5 milligrams per kilogram every 4 hours and weighs 48 pounds. Her mom shows you her bottle of Tylenol from home and is asking how many mLs of Tylenol she should give Donna. The bottle of Tylenol says 160 milligrams per 5 mLs. How many mLs should Donna's mom give to her every 4 hours? Okay, first things first, what do we need? So we are going to want to end up with how many milliliters. That's what she's asking. So how many milliliters of Tylenol is she going to give her per dose? Now our next thing is what's ordered. And we know she's ordered for 12.5 mg per kg. 0.5 mg per kg. 12.5. Okay. Now we're going to need some conversions in there because we have pounds and we have kilograms. So we know 1 kilogram equals 2.2 pounds. And then from there, we are going to end up using the 160 over 5 because that is going to help us convert from milligrams to kilogram per 2 mLs. So let's get started. So we know she weighs 48 pounds right here. Let's get her to kilograms so we can work on that. So we have 1 kilogram equals 2.2 pounds. We can cross off our pounds here and we are good to go. Now we have kilograms, so we are going to work with our 12.5 milligrams per kilogram. We're going to get the 12.5 milligrams up here over 1 kilogram and be able to cross off our kilograms here. Then we're going to be able to use our 160 milligrams per 5 mLs to get rid of our milligrams, so we're left just with milliliters. So we are going to put our 5 mLs up here and our 160 milligrams down here so that we can cross off our milligrams. Then we are left with just milliliters, which is what we need. So we are good to multiply across the top and we get 3,000. Multiply across the bottom and we get 352. Divide them out and we are going to get 8.5 mLs.
I hope all those practice problems were helpful for you. Now let's walk through some key dose calc tips so you don't accidentally make a mistake on your exam. Now the first tip is to make sure that you read the entire question first before you do anything else. This tripped me up many times on my dose calc exam in nursing school. I would start reading the question and then assume, it's a bad word, assume that I knew what it was asking for, and then I would solve it based on what I thought it was asking. But then when I went to double check my work, I found that I was solving for the wrong thing. I had the wrong units or something was off because I didn't actually read what the question was really asking me for. It's so easy to just assume that you know what the question is asking when really it's asking for something else. But you wouldn't catch on to that unless you actually read the entire question in the first place, right? So when you sit down to take your exam, make sure to read the entire dose calc question first before you start to solve it. Now, tip number 2 is to learn the must-know dosage calculation conversions. There are no two ways around it, my friends. You have to memorize these. Like 1 milligram equals 1,000 micrograms, 1 liter is 1,000 milliliters, there's 3 teaspoons in a tablespoon, there's 30 milliliters in 1 ounce, and 1 kilogram is 2.2 pounds. Things like that. When you sit down to take your exam, the exam will not have these written anywhere, so you need to learn them beforehand. And to help make this way easier for you, we have these awesome dose calc flashcards inside the nursing school dose calc box to help you learn these dose calc conversions faster. So we've already included all of the must-know conversions that you need to know, including grains, which many nursing students forget about, but it often shows up on your exam, so you have to know it. Now, the link is down below for you to check out that dose calc box, snag these flashcards. And the next tip is to do as many practice questions as you can, all of them. All the time. Practice, practice, practice. Do all of the practice questions that your school gives you. Do all the practice questions inside our dose calc workbook, inside that dose calc box. It'll help you become more confident, and the better your chances of passing your dose calc exam will be. And there's 3 ways that I can help you more with dose calc in nursing school. Number 1, download this free cheat sheet that walks you through the step-by-step process for acing your dose calc exam. Now, don't miss out on that. Now, number 2, get the nursing school dose calc box so you can snag the flashcards, the workbook, and all of the other goodies to help you build confidence and pass your dose calc exam. And of course, if you want me to hold your hand throughout your nursing school journey, do not miss out on joining the Nursing SOS membership community. It is filled with step-by-step nursing lectures to help you understand everything faster, including a full dose calc course with additional practice questions for you to go through. Plus, you will get access to our fabulous and wonderful nurses so that you can ask questions anytime you get stuck. We are here to help help. The links to all of those things are in the description down below. And if you liked this video, make sure to hit that like button, leave a comment below to let me know that you loved it and that it was helpful for you. And of course, share it with your friends and click that subscribe button and hit the notification bell so you never miss a video. Now click on one of these videos right over here so you can keep rocking nursing school. And as always, my friend, go become the nurse that God created only you to be. And I'll see you next time on the Nursing School Show. Take care. Bye-bye.